Alright, today I'm doing my definition of a triangle, area of a triangle video. So the first thing that we have to do is know the definition of area. Well, the definition of area, area is the number of 1x1 squares that can fit inside a shape, and we can cut these squares up into however big. If we need them in halves, we need them in thirds, we can cut them up however big or small we need them. So after we know that, we have to know the definition of a rectangle, or the area of a rectangle, how to figure that out. So to do that, what we do is we know the definition, or to find the area, it's length times width. So we make a little chart, and we have L things, each with, or L columns with W things in them, and they're not just things, they're 1x1 squares. So we know that to make up to make all these up, you know that they're all 1x1, so you just do multiplication, and then do L times W, and that is going to be your area of a rectangle. So then after we do that, we can start with the triangle. So we're going to have three different types of triangles. The first one is where the base is going to be directly, or the third vertex is going to be directly over the base. So right here, this will make up then a 90-degree angle, and we know we have a base and we have a height. So then the next thing that we do after that, because we don't know how to find the area of this triangle yet, but we do know how to find the area of a rectangle. So all we're going to do is we're just going to come up here and we are going to make a rectangle. So once we do that, we know that the area of a rectangle is length times width, but in this case, which would be h times b, because they're both the same, just labeled differently. And instead of finding this whole rectangle, we only want to find half of it, so all we have to do is half times length times width, which in this situation is base times height. Oops. Half times base times height. So that is how we find out it for the first situation, which is the third vertex directly over it. Second situation, it's gonna be the third vertex is somewhere over top of the base. We don't know exactly where. It doesn't have to be in the middle. We just know it's over there somewhere. So we know we have our base, and our height goes from the top all the way down, and it makes two 90-degree angles. So we're going to label this one 1 and 2, and we know that this is our height. So the first thing that we have to do, we're going to find the area of triangle 1. Triangle 1 is going to be, we know that half base times height is how to find out the area of a triangle, so we're going to just do our half times half of our base. So we're going to call, because base is the whole thing, but we only want to find from here to here, so we're going to call that x, and then we'll come over here and call this one y. So for triangle 1, we're going to do half times x times h, because we only have half of it, or roughly we only have this much of it. We don't have the whole b. And then, so we have that. And for triangle 2, we'll go half times y times h. And then to find the total area, we want to add up the area from triangle 1 and triangle 2. So then if you do it in the formula, it'll be half times x times y times h. And we know that x plus y is equal to b. So you have x and y, we can just change the formula. We can just x plus y, so x and y are equal to h, or equal to b. So half base times height, and it works out again for the second situation. The third situation is going to be where the base, we have a base, and the third vertex is not over the center at all, or over the base at all. So this is going to be our base, this is going to be our third vertex. So then what we want to do is, we don't know the height because this isn't the true height, so we're going to have to make a height from here and make that, so we're going to have to make another triangle. So as we can see from this whole thing, I'll use colors, this whole thing is a big triangle. The orange outline is a big triangle. So first thing we have to do is we have to find out the area of that. And we know that we're going to call this x as well because this is added on and this is now our h. So we know that it's going to be, our area is going to be half, base is going to be b plus x h. So that is our area of our big triangle. So the next thing we're going to do is we're going to find the area of this little triangle right here, right there in the green. So our little triangle area is just going to be half times x times h. And then to find the desired triangle, which is going to be the original one that we had right here in this pink, we're going to take our big triangle minus our small triangle. So we're going to take 1/2 x b h and then half x h, excuse me. We're going to subtract it, distributive property. We're going to get 1/2 or half x h plus half bh minus a half xh. And if we do that, we can see that our half xh's cancel and our half xh's cancel, and we are left with 1/2 base times height. And so that is the three ways. Every triangle falls under one of these three categories, and so just by doing these simple steps, we can figure out that every triangle is half base times height.